All right. Uh, Welcome, everybody. It's 9 o'clock, so let's get this show on the road. So today I'm going to be doing a TEAS test review and test taking strategies. So hopefully everyone's ready and prepared. But this is just going to be a little bit of an introduction into test taking strategies. So hopefully this will help improve your TEAS test scores, and it should also help you with learning a little bit of math and science along the way as well. So these are, important test taking strategies that will, just allow you to kind of relax and to help you navigate through the test. So with any exam, you want to be prepared, right? So you want to study, you want to go through a lot of the background material and do some practice tests. So, when you're going through your prep, you should be starting this about 2 weeks in advance of the TEAS test. That's going to give you enough time to prepare without really cramming and stressing yourself out. So gather your information, gather, maybe a TEAS test review book. You can get these TEAS tests, practice tests through the admissions department. So talk to your admission advisor and they can set you up with a TEAS test practice exam. You can actually get 2 of them. They do have a really good deal with the practice exam. So if you pre-register for the TEAS test through Herzing, they'll knock off $10 and then they'll give you 2 practice exams too. So definitely talk to your admissions advisor about that. And then when you're setting up your appointment, make sure that you're able to arrive early. Okay, so you definitely want to do this at a time when you're not going to be stressed out. Most of the time, that's going to be in the morning before you start work or before you start doing other tasks in the day that may end up stressing you out. So most people do better if they schedule the exams for the morning, and you actually see a slight bump, almost even a half a letter grade higher if you schedule it at a time when you're going to be the most relaxed. Okay, and there's a couple other strategies that you can use also to relax before the test. So arrive early, and then right before you go into the exam, maybe call somebody on your phone and just talk to them about taking the exam. When you talk it out with family members and they're involved, it actually makes you less stressed out. So that's a good strategy. Once you get there, just to call somebody, call a loved one, and just say, hey, I'm going to go to that TEAS test and wish me luck, and they're obviously going to wish you luck. So, and that will actually make you less stressed out and you'll perform better. The more stressed out you are, the more it impedes your ability to recall certain memories. And it actually slows down your memory recall process. So it's a great strategy just to help calm yourself down. And of course, you want to practice, the same routines that you're going to use while taking the exam. So, if you're doing your practice with a cup of coffee, then bring a cup of coffee into the exam with you. That's going to be something that provides extra comfort for you as well. So that's a little tip that you can use to reduce the anxiety. Okay, and all right, so if you do these practice exams, you're going to be familiar with all of the instructions for the different content and topics. So definitely do some practice exams. Ideally, you want to do 2 practice exams, one a week before the TEAS test, and the other practice test is going to be the day before the actual exam. Okay? By spreading these out, you're going to be able to kind of touch up and fine tune any areas that you still may have some problems with. And you don't want to be doing your cramming the day before the TEAS test. So this kind of prevents you from doing like a lot of cramming. You're just going to be doing fine tuning right before the TEAS test. So it's better to actually, do that practice test right before your exam and do your cramming and do a lot of your hard lifting for studying 2 days before. That's going to be the day that you really want to be, studying and putting in a lot of hours with books. So try to schedule yourself that way. So if you can do like a Saturday, that's your study schedule, that's your study day, and then Sunday is going to be your fine-tuning day and the practice exam, okay? And then you'll be ready to go Monday, okay? And so if you space yourself out like that, you'll actually have a nice weekend to do your studying, do your prep, and then on Monday you can go and take that TEAS test, okay? Make sure that you plan for this TEAS test. By doing the practice exams, you'll have a good idea of what time's involved with each one of these sections, okay? And there is a section on reading comprehension as well. I'll talk about a couple of the strategies for reading comprehension a little bit later, but you want to do these practice exams also to get a feel for how much time you have for each one of these sections, okay? And so that's another thing that you can look at just to make sure that you use good time management. Some people get really stressed out. There's going to be a little timer that's actually in the window for the exam, and that will stress some people out. There's a little psychological trick that you can use to own that time. And so if you own a wristwatch or those Apple watches or any of those watches, bring that along, okay, and set your watch as a timer, and that will actually psychologically it will allow you to own your time. It's one of those things where if you're wearing something and this is something that's part of you, you actually take ownership of it and you'll be less stressed out by that little timer. Okay, so plan on using your allotted time correctly. Maintain a positive attitude. Again, that's going on with like the calling somebody that that cares about you, talking it out, talking about your feelings before the exam, and usually this is best done in the morning, so schedule your exam ideally for the morning or time that you're not going to be very stressed out. All right, and then starting the exam, okay? So they always tell you go with your first impressions, and that's absolutely true. You want to be just answering the questions. If you know the right answer, definitely put that down and rely on those first impressions. Usually that's going to be the correct answer, okay? And of course, using proper time management, you're going to be able to finish the exam early. Now, talking about time management, that often comes into play with that reading comprehension section because people will spend too much time reading the details of each of those passages. So that's going to actually set you back on time. So ideally what you want to do for the reading comprehension section is you want to just skim those sections, okay? Skim the paragraph, take note of the first sentence and the last sentence of each one of the paragraphs, and then go directly to the questions. And in the questions, okay, you're going to look at the options for the answers and then go find which one is correct, okay? And it wouldn't matter if you read the entire passage or if you just skimmed it, you're going to answer these the same way. So what you're going to end up doing is when you read the question, you're going to go back to that passage and you're going to look for the answer. So if you read through the passage really slowly, it's going to really set you back on time. So skim the sections, look for the answers in the passages, and that's often going to lead you to the correct answer. So use that strategy for the reading comprehension. Okay. And then I'll give you guys some keywords to look at as well. These are called key modifiers. You want to pay attention to certain words in the questions and also in the answers that will help lead you to the correct answers. All right, and hopefully you'll have a little bit of time left over to review some of your answers as well. You don't have to worry about an essay question, so you don't have to worry about grammar and spelling. It's all going to be multiple choice. So just make sure that you allot yourself enough time and you manage your time well. All right, and of course, with your practice sessions, you want to analyze your performance, look at which sections you need to go back and review just to do that fine tuning, and then you'll be ready to go. Okay, so I'm just going to give you a couple quick little hints on true and false questions. So when you're doing true and false, if you don't know the answer, mark it true, okay? And the reason is it's the split for true versus false on most exams is going to be right around 60-40. So the percentage-wise for it being true is more likely to be true than false by about a 60-40 split, okay? And that's just because as instructors, okay, we want to test what you do know. And that means most of the answers are more likely to be true, okay? And we're going to have fewer questions that are trying to trick you or that are false, okay? And so that's just how we write the exams. It's usually right around 60% are going to be true. Now, every now and then you'll have a exam that maybe doesn't follow that ratio, but most of the time that's about what it is. So if you absolutely do not know the answer on true and false, you're better off answering true. Okay, now, what are some factors that will make a statement false? So these are going to be words that you want to watch for, okay? And these are probability words, okay? So in the realm of probability, these make that question very extreme, okay? It's like an all or nothing kind of question now, okay? And in the world of statistics, we don't play with all or nothing very often. It's very rare that it's 100% this or 0% this, okay? And even when we think of like, our body performance, right? You can't give 100%. It's impossible, okay? And I always find it funny, when athletes, say that they gave 110%. Okay, well, I just kind of laugh at that because I think it's impossible. It is impossible, okay? At their very best, and even like a world-class sprinter like Usain Bolt, world record holder, he can maximize his performance to 97%, okay? And he can maintain that for about 10 seconds, okay? So after 10 seconds, his performance continues to decrease from 97 to 95 to 94, so by the time you run 20 seconds, you're at about 92% of your max, okay? So watch out for these extreme modifiers, okay? It's an all or nothing kind of scenario. So these words are going to be all, nothing, none, best, absolutely, always, never, worst, absolutely not, only, everybody. And I'm sure if you have kids and one of your kids comes up to you and is like, hey, all my friends are doing this, you kind of know that, all right, they're pulling your leg. You know that not all of their friends are doing it, and they're trying to persuade you with one of these extreme modifiers. Most people can see right through that. So if you see one of these words, everyone, no one, nobody, everybody, it's almost always false, or it's almost always incorrect. So if you see this also in one of your answers, and that's where it comes into play for multiple choice, if you see this in one of your answers, just cross it off. It's almost always wrong. All right. These are terms that you want to watch for. These are modifiers that make it more true. So notice how they're more statistically accurate, okay? Frequently, a majority of the time, likely, probably, might, often, many, may, sometimes, much, most, and unlikely, okay? These are modifiers that you want to watch for that kind of help guide you to the correct answer. So if you see one of these, it's more likely to be correct. Okay, and then, true and false, if you have like some of these statements that have prefixes like un, im, and miss, okay, just watch out for those. They often will lead you to false answers. Double negatives, okay, often those are going to be just false because they're trying to trick you. They sound tricky, and they are trying to trick you. All right. And of course, no substitute always for the truth. So if you know the answer, boom, done. All right, and there's always a couple practice tests, practice quizzes that I was putting here, but you can test yourself on these. When it comes to answering multiple choice questions, so these are going to be specific just for the multiple choice. Of course, you always want to kind of formulate what you think is going to be the answer first when you read the question, and then look for that in one of the selections, one of the answers. Okay, so if you know what the answer should be, find the one that matches. Okay, if you are uncertain, we want to try to narrow it down to one or two choices. So often you'll find pairs. You'll find either a pair that are similar, or you'll find a pair that are opposites of each other. So if you see these, those will help also guide you to the correct answer. So watch for the pairs, watch for either like terms or opposite terms. Okay, and then you can use process of elimination to cross off the other ones. And that's a good strategy that you can use then to eliminate some of the answers. Okay, now there's a special case that occurs here with numbers. Okay, when you have a number list, and say you have 1, 2, 3, 4. Okay, most of the time when we write an answer list, okay, especially for numbers, it's going to be one of the numbers in between. Okay, so on this PowerPoint, I have 4 numbers, and you'll have 20,000 feet, 3,000 feet, 8,000 feet, and 11,000 feet. Okay, so we have a really high number and a really low number. Those are most likely not going to be the correct answer. So you can already focus on the 2 numbers in between, 8,000 and 11,000. The other thing that you should notice here is that the gap, the number between 11,000 and 20,000 is 9,000. It's a big gap. Same with this gap between 3,000 and 8,000. It's a bigger gap. And the gap between 8,000 and 11,000 is the smallest gap. And that's the other thing that you want to look at when you're looking to cross off answers. So that points you to these 2 as a possible answer. And then, at least you have a 50-50 chance now. And on the TEAS test, depending on which program you want to get into, if you want to get into the nursing program, you need to get like at least a 60. Well, if you can narrow everything down to a 50-50 shot, you're ready at a 50%. And so you just have to get a few more right, and you'll be right in that 60 range with ease. Okay, now this is critical. This is one of the keys that you should definitely pay attention to. So in the answers, okay, the longer the answer is and the more descriptive the answer, the more likely that's the correct answer. Okay, so let me repeat that. The longer it is and the more descriptive it is, the more likely that's the correct answer. Okay, so watch for that. Okay, watch for those answers that are a little bit longer. The real short ones are usually just quick statements, and they're just throwaways. So you can almost just kind of pass over those and just eliminate those. Okay, and then there's going to be some that are sometimes opposite of the more descriptive ones. Okay, or there might be something that's there to try to persuade you. And if they're trying to persuade you, they're often going to use one of those extreme modifiers. So watch out for those extreme modifiers, and then just watch for which ones have good description and are a little bit longer. Okay, and so of course there's a couple practice tests here. So when we go through practice tests, we can look at some of these questions, and we can just highlight one of these. All right, so for the first one here, we have which of the following is not a mammal? Okay, and the key here when you're looking at these is you should see a couple pairs, okay? And so we have a pair here that are both found in water. So we have a shark and a whale, okay? The other ones, a bat's gonna fly, a horse is gonna be on land. And so that's the pairing, that's the way you wanna think about this, okay? And then which one of these would be a mammal. It's the one that actually has live birth, hair, and things like that, and that's going to be your whale. Okay, and when we have numbers, we have Canada's population is closest to about, we have 5%, 10%, 15%, 20% of America's population. Okay, and the best answers are either going to be 10 or 15%. Okay, America's population is just over 300 million. And so that's going to put you at either 30 million or 45 million. And the best answer is 45 million. So that's going to be 15%. But you can see it was one of the number sets that were in between. Same with this one. The permanent set of teeth in a human is going to contain how many teeth? And here's our number list, 28, 30, 32, and 34. The correct answer is C, 32. Okay, so again, it falls in between the upper and lower ranges. Okay, which of these birds does not have feathers? Okay, in order to be a bird, you have to have feathers. Okay, so this is one of those that's a little bit tricky. Okay, but you'll see a couple pairs here. The pair are similar. So you'll see eagle and robin, both of these fly. Okay, and so now it's kind of pointing you toward all of them. Okay, now we have two outliers here, penguin and ostrich. Penguins in the sea, okay, and ostrich runs around on the land. Okay, but both of them actually have feathers. All right, and let's go to another quiz, but you can take a look at some of these quizzes on your own. Or you can take just some random quizzes that you can find online too. It's helpful just to practice doing just random multiple choice and put the strategies to work. Try practicing some of these strategies. So for instance, if we were to apply the strategy of which one's most descriptive, okay, well, we can take a look at like number 4, which of the following is an example of tyranny of geography? Okay, industrial pollution, flooding caused by monsoon, economic disparity caused by socialism, or none of the above. Okay, so best answer there was actually C. This one I always kind of think is funny. What makes a skip different from a hop? Okay, and a walk. So I'm sure all of you at some point in your life have skipped, maybe hop, and of course walk. But what is actually the definition of all of these? Okay, and so the best answer here is a skip can only go in one direction. Okay, so you can only go, you're not changing directions when you're skipping. The other ones you can hop in all different directions and change directions while you're doing it. Another example of one that's kind of longer. When formulating goals into specific activities, one should, and you can see the different, the different choices that you have. So you can give priority to activities that are done the easiest. Okay, so do the easy ones first, maybe. Okay, overrule any previously included appointments. Okay, well that really has nothing to do with it. That's a throwaway, and it's pretty short. Okay, and then we have make sure activities have a date, time, and a place to ensure their fulfillment. Okay, that one's very descriptive, and it's pretty long. And yes, that is the correct answer. Okay, the last one is another one that's kind of a throwaway. So wait 2 weeks or until no longer busy to start the activities. Okay, well, in practice, maybe you want to free up some time so that you can focus on it, but it's not really related to formulating goals. Okay, and again, I recommend just practicing some random multiple choice questions just so you can, practice recognizing and using these strategies, practice utilizing those key modifier words and look for the modifiers, okay? There's a whole bunch of, just random quizzes that you can find. If you use the search engine or the browser Bing, they'll have a multiple choice quiz every single day. So you can just go to that and just practice. There'll be 10 questions there and see how you do. And just look for those key modifiers and those strategies. Okay, now just to complete just basic test prep. For answering matching questions, you always want to use process of elimination for matching questions. So, as you're filling in the correct answers, cross them off so you don't accidentally reuse any. Okay, and start with the ones you know, and then as you're crossing them off, you'll be able to find answers to the other ones. Okay. As far as fill in the blank, so this is a little bit more more direct. You have to know the answer here. Sometimes you'll have a library of words that you can use. So if you have the library words, it's very similar to the matching. Then just use process of elimination, cross off the ones that you use as you're filling in the blank. Okay, you'll have no fill in the blank questions for the TEAS test. You might have a couple matching, but they'll be very short, with maybe 3 options and no more than 4 to 5 options. Okay, and these are just some practical tips for essay questions. Ideally, if you're doing an essay question, you want to write just a little outline just so that you can organize yourself. And you can put little notes in with the outline so that you know what your talking points are. And then when you actually write it, just write with good paragraph structure. You also want to have your topic sentence first, and then you have your supporting detail, and then a closing sentence for that paragraph that kind of mimics what you had with your topic sentence, the first sentence. All right. And of course, most of the essay questions now are computer-based, so you don't have to worry about writing clearly. There'll even be a little bit of spell check on there for you, so you don't really have to worry too much about spelling and those issues. So and writing clearly. Okay, so that covers the basic strategies for the test taking for the TEAS. Okay, now we're going to get into some of the math, and then we'll get into some of the science. So we're going to do math first, and then we'll go into chemistry because they align pretty well. So whenever you're doing conversions from decimal to fraction, okay, you want to pay attention to how many decimal places you have. Okay, so if you have 2 decimal places, that means you're going to have a 1 with 2 zeros. So you're going to put 75 over 100. Okay, and backslash 100. Okay, and so now you want to reduce the fraction. So you need to look for common multiples. Okay, and you can make a multiple tree if you want to do it that way, or there's a couple little quick hints or quick tips that you can use. So one of them is the 5 and 0 rule. So if you have a number that has a 5 and a 0 in it, you can divide both of those numbers by 5. Okay, so if I divide 75 by 5, I'm going to get 75 by 5 is 15. And then if I divide 100 by 5, that is going to be 20. Okay, and again, we see that same rule, 5 and 0, right? So again, we can reduce this again. So we can divide each side, the top and the bottom by 5 again, and so now you'll have 3/4. Okay, the alternative way is just to make a factor tree. So I know that 75, I can divide that by 25. So there I would have 25 times 3. Okay, well, 25 can also be reduced to 5 times 5. Oops, let's get rid of that. So 5 times 5 times 3. Right, and then for my factor tree on the denominator side, okay, I have 100. So there I can have 4 times 25. Well, 4 can break up into 2 times 2, and 25 can break up into 5 times 5. Okay, and just cross off the terms that are similar. So you have 5 times 5 on the top and 5 times 5 on the bottom. So you can cross off both 5s on the top and both 5s on the bottom. And you're left with 3 over 2 times 2, so it's 3/4. That's the long way to do it, okay? But that's one of the ways you can do it. So there are multiple ways to do it, but you know, if you're in a hurry, the 5-0 rule works very, very well. Okay, so here we have 0.9, okay, and if you have 0.9, okay, there's only one decimal place, so we're only going to use a 1 and 1 0. So this is going to be then 9 over 10. Okay, and that doesn't reduce any further. It's just going to be 9/10. Okay, and if you have 0.5, we're going to put that as 5 over 10. Okay, and again, the rule here applies. We have a 5 and a 0, so we can divide 5 into both of those. Okay, so that's just going to be 1 over 2. So we have 1/2. Now, if we have a decimal that has a whole number in front of it, okay, you can either just leave the whole number outside of the fraction, okay, and you could write 1 and 13/100ths, okay, or you could just write it as 113 over 100, okay. You'll get the same answer. You're going to get 1 and 13/100ths. Okay, now the final one is percent. So you have to always remember that percents are out of 100. So we always make a percent, you know, out of 100. So if you have 72%, that's out of 100. So you just put it over 100. So you have 72 over 100. Okay, now we don't have a 5 and a 0, but we have 2 even numbers. We have an even number in the numerator and an even number in the denominator. So now you can use the quick tip of the even number rule, or you can just divide the top and the bottom by 2. So here that reduces, we're going to divide the top and bottom by 2, so you have 36 over 50. Okay, both of them are still even numbers. Okay, and so now this will reduce to 18 over 25. Okay, now they're no longer even numbers. Okay, and so 25 is 5 times 5, 18 is 2 times 9 or 3 times 6. So we can't reduce this any further. So this is the final answer, 18/25. Okay, now you're probably asking, is there going to be a calculator? And the answer is yes. Okay, so you will have one of those old-fashioned calculators that you can use for the TEAS test. Okay, you're not going to have a lot of functions with it. It's not going to be a scientific calculator, but it will be just your basic calculator. And so for fractions, you can still just punch them in. So just punch in the fractions here, you know, and if you're looking for your calculator on the PC, you can find it under your Windows accessories. And it should be, let's see, it is tools. Should be, let's see, math input panel. So you can use this, or you can use, or it's not right there. Or you can use this calculator. Now this calculator, you can expand by just clicking on this left-hand button here, and you can make it a scientific calculator. If you want to do more functions, you can also do conversions here. So if you need practice doing conversions, this will help you out. You know, if you want to do weight to mass, you can do kilograms and pounds. And so all of these are you know, functions that are in just that standard calculator. You just have to open it up. All right, and so I would recommend just doing all of these right on your little calculator. So take 5, and you're going to divide that by 8, and that's going to equal 0.625. Okay, so all you have to do is be able to punch this into your calculator correctly. So then we could also do 3 divided by 7. Okay, and that's going to be 0.4285. They're going to ask you to round to certain places. So if they're going to ask you to round to the hundredths, you would look at the thousandths position to round to the hundredths. If they ask you to round to the tenths, you look at this number, the hundredths, to round to the tenths. Okay, so notice here, if we would round to the hundredths, that would make the answer 0.43. If we were to round to the tenths, we would round to 0.4. Okay, because the 2 is less than 5, it wouldn't make this 4 go up to 5. Okay, so that's your basic rounding as well. Now, one other thing that I want you guys to be able to do is to apply a little bit of number logic. When you're looking at these, how do you know that the answer that you punched into the calculator is a good answer? Okay, so you should have a little bit of practice with number logic. So ideally here, what you want to do is think about what's my halfway point of the denominator. Okay, so look at the bottom number, and what's half of 8? Half of 8 is 4. Okay, so if I'm doing 5 over 8, then my answer better be more than 0.5, because 0.5 would be half. Okay, so always think to yourself, like, what does a good answer look like? Okay, that way you can have that internal check system operating while you're punching it into your calculator. Because every now and then, you're going to punch a number into your calculator incorrectly. Okay, but at least this way, when you look at it, you'll question that result and be like, that doesn't make sense. Let me punch that in again. Okay, so what's half of 33? Half of 33 is going to be 16.5. Okay, and so if my question is 17 divided by 33, I know my answer has to be just a little bit more than 0.5. Okay, order of operations. So first things you always do. Okay, anything that's in a parentheses is the first thing you do. So parentheses is the first thing, okay, and then exponents. Exponents and squares are the next two most important things. Okay, then multiplication, division, and then addition and subtraction. So addition and subtraction are last. Okay, so again, parentheses, then exponents and squares, then you have multiplication, division, then you have addition and subtraction. So by those rules, we should be multiplying 5 times 5 first. So we would actually have 5 plus 25. Okay, and then that's going to equal 30. Okay, so that's how you do these. In the next one, you have 48 divided by 6. So that's going to equal, we have to first do the division. That's going to be 48 divided by 6 is equal to 8. And we have plus 3. So my answer is 11. Okay, now I have a set in parentheses. So I have 10 minus 3 in parentheses. So I have to do that first. So that's going to be 7 and then times 7. So my answer is going to be 49. Okay, now I have 5 minus 72 divided by 9. Okay, I need to do the 72 divided by 9 first. So I'm going to have 5 minus 8. Okay, and my answer then is going to be a negative 3. Okay, now for the last one here, you'll notice there's 4 plus 4 in parentheses. So I have to do that first. Okay, but I also have 8 times 2 here. And it's isolated by itself. So I could actually do that at the same time. So I have 4 plus 4 in parentheses. So that's going to be 8 and minus 4. And then 8 times 2 is going to be 16. So now I can just add everything up. Okay, and so you can go from left to right and just add everything up. So 8 minus 4 is going to be 4, plus 16 is going to be 20. Okay, so that's how you do order of operations. Now, one variable equations. So this is about as far into algebra as you need to be able to go in the TEAS test. So what I like about all of these equations is you can check your work. So when you're done solving for X, put that solution back into the original problem and check your work. So you should be able to check your work and prove that all of your answers are correct. Okay, and that's always a good feeling if you are done with the exam and you know that, hey, I aced it because I checked my work, they were all right. So here you have X plus 2 is equal to 11. So the way we set these up and the way we solve these is we have to move all the variables to one side. The variables are the X's, the Y's, A, B's, and all the letters, okay? And any numbers that are attached to the letters. So if you have 5X, you would move 5X to one side, and all the other numbers, the whole numbers, you're going to move to the other side, usually to the right, okay? In order to do that, so in order to move this 2 to the other side and join with 11, I have to subtract it from the left. And that means I subtract it also from the right. So I'd have X plus 2 minus 2 and equals 11 minus 2. So then I would have X is equal to 9. Okay, now I can solve for X. So I put 9 back in here. So 9 plus 2 is equal to 11. Okay, so my answer when I solve that is going to be 11 equals 11. Okay, and in mathematical terms, that's a true statement. Okay, so that's all you're looking for. You want to make a true statement. So you want to solve for it and verify that it's a true statement. If you have 10 equals 11, that's not a true statement. And that means that your answer is wrong. Okay? So, moving on to the next one, I would move the 12 to the other side by adding 12 to both sides. So, a negative 12 plus 12 cancels that term because that would be 0. And then we have 5 plus 12, and that's going to be 17. And again, we could check our work. 17 minus 12 is equal to 5. So that's a true statement. Okay, now you'll see that we have a number in front of the variable here. So we call that a coefficient. Okay, so we have a coefficient in front of the variable and minus 5. So now in order to move that whole number, the minus 5 to the other side, we have to add 5. So then you'll have 7x is equal to 35. And then of course, now we need to reduce this to one single x. So we're always solving for 1x, not 7x's. So if we would stop here, we'd say, all right, if we have 7x's, it's equal to 35. But we want to solve for what one individual x is. So then we divide by the coefficient. So in this case, we would divide by 7. So 7 divided by 7 is 1. So we're now to 1x. And 35 divided by 7 is going to be 5. Okay, for the next one, we have a coefficient of 12 and a variable x. So here we would add 10 to both sides. Okay, so a negative 10 plus 10 is 0. And then on the other side, you have 12. So now we have 12x equals 12. Okay, and so my final answer by dividing each side by 12 is going to be x equals 1. Okay, and the last one, of course, we have to have coefficients on both sides. So we're going to have a 3x and a 7x. Okay, so 3x plus 5 is equal to 7x minus 11. So we want to move all the x's to the left side and all the whole numbers to the right side. Okay, so we can subtract 7x from both sides. Okay, and so that's now going to give me a negative 4x. And that's going to equal, and to move the 5, we have to subtract 5 from both sides. So we have 5 here minus 5. And so a negative 11 minus 5 is going to be a negative 16. Okay, now we can divide both sides by a negative 4. So we would have x is going to be equal to And because you're dividing both sides by -4, when we divide -16 by the -4, it's going to turn positive. So x is going to be 4, +4. Okay, and of course, you can put this back into the original solution, the original problem, and check your work. So if we have 3x, so 3 times 4 is going to be 12 plus 5, that's 17. Okay, and then if we take 4 times 7, that's 28, minus 11, that's also 17. So again, we have 17 is equal to 17. That's a true statement. Okay, now there are going to be some story problems. Okay, and there's also going to be a little bit of statistical analysis. So the statistical analysis is very, very easy. So what you want to remember is, first, you need to know 2 terms. You need to know the mean, and the mean is always the average. Okay, the other term is median. Okay, and the median is just the middle number. Okay, so if you have a number series 1 through 5, 1, 2, 3, 4, 5, the median is the middle number 3. Okay, so that's the median. The average, the mean, is you have to add up all those numbers, okay, and then divide by the total number of numbers that you have there, and that'll give you the mean, the average. Now, when we review data, okay, we always look at the distribution around the mean. Okay, and then what that means is we can have a symmetrical distribution, and you guys will know that as a bell curve. Okay, so that's a perfect bell curve. The middle, okay, is the mean. Okay, and so that's what we mean by symmetrical. The left side is equal to the right side, with the middle, the dividing point, being the mean. Okay, and so if you took at numbers from like 1 to 100, okay, the average is going to be 50, and so you'd have a perfect bell curve from 1 to 100. Okay, and that's symmetrical. Bimodal means that you have 2 averages, 2 means. Okay, and so you'll have one symmetrical curve on one side with one mean, and then you'll have another mean on the other side. So you have 2 means, and you have a symmetrical curve around both means. Okay, and so in practice, where do we see this? Well, you see this often in a classroom. Okay, and so just imagine, you know, that you have 2 groups of students. Okay, one group of students aced the test. Okay, and they got all A's and B's. So the average in that group is really, really high, maybe 90%. Okay, that's the first curve. And then unfortunately, the other group failed it. Okay, and they got all, you know, D's and F's. So their average might be at 50%, but that's all failing grade. But you have 2 symmetrical curves. Okay, but it's bimodal, which means you have basically 2 curves. Okay, now skewing left and skewing right. Okay, skewing left means that the average, okay, the mean, you know, is a little bit skewed to the left if it's a really high, if it's a really, let's say your students did really well on an exam, okay, well then your average, your bell curve might skew a little bit more to the left. And that means that more people got A's than F's. And so you'll still be symmetrical, but it'll be more like a ski slope, a hard rise and then a long tail off. Okay, that's skewing to the left. And then skewing to the right just means that you have a long tail up and then more people failed the exam, okay, and then you have a quick drop off. It's still symmetrical, but it just means that you have a higher number of high numbers or a higher number of low numbers if it's to the right. Okay, uniform. Okay, that means that no bell curve is established. It's a straight line. Okay, and so uniformity is just a straight line. So those are the terms that you just need to know for the math review. You need to know a couple equations for geometry. Okay, so the area of a square and a rectangle are both length times width is equal to the area. Okay, always multiply length times the width. A square is just a special type of rectangle that has all sides equal. Okay, so the same equation applies. The area of a triangle is just half of a square or a rectangle. Okay, so you can also think of that as just half of the length times the width. Okay, but most of the time they just call it half the base times the height. Okay, it's really just saying half of the length times the width. And the one that you might need just to commit to memory because you don't use it very often is going to be the area of a circle. So the area is equal to the radius squared times pi. And for pi, just use 3.14. Okay, now story problems. So for story problems, I want you to practice using conversion factors or equivalence factors. Okay, so when you're doing these first couple are pretty straightforward. So just make sure you read them carefully, okay, and then apply, the information. So you have your salary is $40,000, and you'll get a 5% increase. Now, what's the trick here? The trick here is reduce the percentage to a decimal and then multiply. So if you have 5%, you can just write that 5 over 100, okay, and that reduces to 0.05. If you want to keep it as a fraction, you can do it that way too. What you'll end up doing there is you would take 40,000 and multiply by 5, and then divide that number by 100. You'll get the correct answer. The answer for this would be $2,000. So how much more would your salary be next year? $2,000 more. Okay. It's not asking for what will your salary be. So it's not asking $42,000. It's just asking how much more. So be careful when you read through these. Now the next one, of course, is the other situation. So how much will you be making next year? So it's asking for what is your salary next year. So again, you can use 2 over 100, multiply that by 50,000. So 2 times 50,000 will be 100,000. And you take 100,000 divided by 100, and you'll get an answer of $1,000. So your raise is $1,000. You add that to 50,000, and your answer will be 51,000. Okay. Now, for these next two, you'll notice that these two are what we call equivalence factors. Okay, so when we write these out, you'll see that 15 hours, okay, is equal to a 2-week period. Okay, now we want to write this as a fraction. So how am I going to write 15 hours is equal to 2 weeks as a fraction? Okay, there's only 2 ways that you can do that. Okay, so I recommend practicing and writing them both down. Okay, so I can write this as 15 hours divided by 2 weeks. So notice it's a fraction now, by 2 weeks. Okay, or you can just flip it. Or every time I'm practicing 15 hours, it's over a 2-week period. And that's basically what we're saying. Okay, so those are the 2 ways that you can write it. So then, how are we going to apply this? So when you have one of these, you always want to start with really the end point. How many hours will I practice in 2 months? So I need to start with 2 months. It's very similar to dosage calc. My order would be 2 months. That's the period of time. That's the order. So I would start with 2 months. Okay, and so now I work my way backwards. So I take 2 months. I'm going to multiply this out. So this would be times. And now I need a fraction. So I need to convert months to weeks, right? So how many weeks are in a month? Okay. And so I need to be able to cross off my units. So whatever unit I'm starting with here needs to be in the denominator in the next step. Okay, so I have 4 weeks. Okay, and I'm going to make this a fraction here by just underlining it. Okay, and then this is going to be 1 month on the bottom. Get rid of that underline. that. Okay, so this is going to be 4 weeks, 1 month. And just space it right. There we go. So now we have a fraction. And notice the units line up opposite of each other or on the diagonal. So I can cross off these units as I'm going across. Okay. And now we'll just continue on the top here. Okay, now the next term has to have weeks in the bottom. Okay, well, I have 15 hours every 2 weeks. So that's my next term. So I'll have 15 hours on the top. Okay, and on the bottom, I'm going to have 2 weeks. Okay, and I'll underline that to make that a fraction. Okay, so 2 weeks now on the top. Let's get rid of that underline. And it wants to know how many hours am I practicing. So I'm set up now. My final answer will be in hours. The weeks will cancel off, the months cancel off, and my answer, I just multiply straight across the top. So 2 times 15 would be 30, times 4 would be 120 hours. And that's the correct answer. So practice using those equivalence factors. Practice setting up the solution with the units on the diagonal. If you do that, you're going to be so much more prepared for dosage calc in the future. But you'll also start to enjoy, you might start enjoying, some of these story problems. I don't know, a lot of people just dread story problems, but it gets easier once you learn how to set them up. Okay, and so for this one, and a little trick that I do for these is once I have a solution set, I just, I'll try to copy and paste that in here. Let's see if it'll do it. There we go. Let's just shrink that down a little bit. There we go. All right, so now how many miles would I drive in 1 week? So instead of months, now I'm starting with week. Okay, and I'm only starting with 1 week, so that's my starting term. Okay, and then I need to space this out so we have our fractions. Okay, and my next term now has to have weeks. So I'm spending 3 hours per day driving to work and back. Assuming a speed of 70 miles per hour, how many miles would I drive in 1 week? So I've got the 1 week. The next thing that I need is how many days are in a week, right? Because I'm driving 3 hours per day. So we'll say this guy's a workaholic and he's working 7 days a week. Okay, so we have 1 week and we have to have 7 days on top. Okay, notice that wasn't in our question here, but our units logically tell us what term has to be next, because we can only go from weeks to days. Okay, the next term, now I have something with days. I've got 3 hours per day. So now I can put that in, and days has to be on the bottom. So I have 1 day on the bottom. Okay, and on top here, this has got to be 3 hours. All right, now, next up, I have 3 hours and I need one more term. So how can I convert that into how many total miles? Well, I've got 70 miles per hour. Well, that's actually a fraction. So I have 70 miles every 1 hour. Okay, and so I can multiply this. Okay, and so now I'm going to have 70 miles on top. Okay, and then on the bottom, that is going to be for 1 hour. Okay, and notice again, if I follow all of those units, right, I can cancel them off on the diagonal. So weeks and weeks, I can cancel both of those. Days and days, I can cancel off both of those because they're on the top and the bottom. Hours cancels, and my last unit, the only one that doesn't cancel, is miles. And that's what it's asking. How many miles would you drive in 1 week? Okay, and so then you just take 70 times 7, that's going to be 490. And then 490 times 3 is going to be 1470. Okay, so that's how you do those story problems. And that brings us to the next part, which is a list of all of your conversion factors. So again, when you look at the common ones that you're going to use, okay, some of the most common ones you're going to use are, pounds to kilograms. So there's 2.2 pounds for every 1 kilogram. Okay, centimeters to inches. There's 2.54 centimeters for every 1 inch. Okay, so you can use this. You can find them all up here, and then you can just use this conversion chart, or you can look them up online too. But this has all of them here, and then you can use that to solve these conversions. So for instance, this one, 233 pounds to kilograms, I start with 233 pounds, okay? And then I'm going to line up the units. So pounds has to be on the bottom here for my units. So that's 2.2 pounds, and 1 kilogram is on top. So that means pounds cancels, and I'll divide now 233 by 2.2. So basically what you do is you're going to multiply across the top. So 1 times 233 is going to equal, right? So 233 times 1 is 233 on the top, okay? And then on the bottom, I multiply across the bottom. So I have 1 times 2.2 there, okay? And so that means I'm going to have divided by 2.2. And I'll just make that fraction quick, okay? And so that's my solution set right there. And the only unit that's associated with it is still kilogram, because the pounds canceled out. So I gave you a couple extra ones there that you can practice, but just for time's sake, I want to move on to the next term. So now we're getting into the topic of chemistry, okay? And for all the questions, I'm just going to answer all the questions at the end. So if you have any questions as we're going, just put it in the chat, and I will get to them at the end of our webinar. All right, so for all of the science ones, I have some materials here that will give you a picture of what you're looking at, but then also, we'll go through the terms. So the important thing here is that you know the terms, and then some of them I also have already listed for you. So the basic structure of matter is an atom, okay? And every element has its own unique atom. Okay, so you probably have heard of the periodic table of elements. Okay, that periodic table of elements, okay, has basically a list of 118 elements, and they all differ by just 1 proton. Okay, and so now we have to go through what is actually the structure of an atom. Okay, so each atom is going to be made up of subatomic particles. Okay, and so these are protons, neutrons, and electrons. Okay, now pay attention to these pluses and minuses. Those are the charges associated with the subatomic particle. Okay, so electrons are the smallest. Okay, and they don't really contribute much to a mass, because they're 2,000 times smaller than a neutron and a proton. Okay, a proton defines what element you have. So the number of protons defines what your element is. So for example, if you have hydrogen, it has 1 proton. If you have helium, it has 2 protons. Okay, if helium loses 1 proton, it becomes hydrogen. Okay, it's that critical. The proton defines the element. Okay, and that's actually what we call the atomic number. The atomic number is the number of protons. Okay, now the proton is positively charged, the electron is negatively charged, okay? And some of you may have experienced electrons. Electrons are what we see as a stream of electricity. They're negatively charged, okay? Now, the other way that I remember this too is if you look at proton, it has a P for plus, okay? So that first letter tells you, hey, this is plus. And the electron, okay, it's negative because if you ever got shocked with like static electricity, it's kind of a negative feeling, okay? So just remember that's gotta be the negative one. Now neutron sounds like it's neutral, right? And that's exactly what it is. So the neutron is neutral. It means it's not positive or negative, but it helps kind of stabilize the nucleus. Now in the nucleus, that's where you have the proton and the neutrons. Okay, so this is a helium atom right here. So there's 2 protons, so that makes it helium. Now the number of electrons will equal the number of protons because every element on the periodic table is 0 charge. So when you do chemical reactions, you can exchange electrons, and that's where you can get pluses and minuses. For example, you can get sodium, that is Na plus 1. Okay? That means that it lost an electron during a chemical reaction, and a common counterpart is going to be chlorine. And chlorine then receives an electron during that chemical reaction, and it becomes -1, which means that it acquired 1 electron. But when you look at the periodic table, they're all 0 charge. It's only after you do a chemical reaction that they can develop charges. Okay, so that's our protons, neutrons, and electrons. Now, isotopes, okay, isotopes means that you can have a different number of neutrons in the nucleus. Okay, the protons never change, but you can have a different number of neutrons in the nucleus, which can give you multiple species of an atom. Okay, so for example, I can have carbon 12 and I can have carbon 14. Okay, carbon 12 is telling me that that's the weight, it's carbon 12. That means I have 6 protons and 6 neutrons. Carbon 14, okay, is telling me that it's a little heavier, okay? And it still has to have 6 protons. It can't have more protons or it's no longer carbon. But it now has 8 neutrons. Okay? And you can just take that carbon 14, that 14, subtract 6, and you'll get the neutron number. Okay? And that's how we solve for the isotope number. Okay, now, going over here, we have the periodic table. So all of the elements are arranged by ascending proton number. So as you go across, we're just adding 1 proton. Okay, so I can start with hydrogen. That's got 1 proton. Helium has 2 protons. Then I would go down to the next level, which is going to start with lithium. That's going to be 3 protons. Beryllium is going to be 4. 5 is going to be boron, 6 carbon, 7 is going to be nitrogen, 8 is oxygen, 9 is fluorine, and then and so on and so on. So since we mentioned fluorine, you can see this is what it would look like on the periodic table. So this is the atomic number. It's the number of protons, okay? The ion charge, this is when it does a reaction, this is the ion that it's going to become. So an ion, and I put down the definition here, is going to be a charged atom, okay? So whether it loses an electron, okay, or gains an electron, these are both types of ions, okay? Now, if it's a positively charged ion, we call that a cation, okay? And notice the cation has a T in it for a plus, okay? So the cation has a plus sign right in the word. The anion doesn't have a plus sign, so it's negatively charged. So that would make fluorine, if it does a chemical reaction, it's going to become an anion. Okay, now what are some other things here? So we have the atomic mass. The atomic mass is going to be the number of protons and neutrons. Now, it shows that it's 19, okay? And so that means in nature, okay, and there's multiple species of fluorines. And in nature, we add up all the different isotope species and we average them out. And that's what the atomic mass is. It's an average of all the isotopes that are out there. And for fluorine, it's going to be 19. And so that means that the normal fluorine species is going to have 9 protons and 10 neutrons. Okay, and that of course is also going to be our mass number. The mass number is the number of protons and the number of neutrons. All right, now types of matter. So this is probably a little bit of a review for you guys. So matter can exist as a solid, liquid, or gas. And there's also a fourth state now too, that's a plasma. But you just have to know solids, liquids, and gases. So a solid is going to be a crystal structure. Think of ice. Ice is a solid state of water, okay? And it crystallizes into a hard solid. But it's really a crystal, okay? And the atoms are locked into place. And that's the key thing you want to remember. Atoms aren't moving. In liquids, the atoms are flowing past each other, okay? So they're moving, atoms or molecules, they're flowing past each other. In mixtures, in a gas, they're no longer interacting with each other. There's so much energy, and that energy usually is derived from heat. There's so much energy that they're sped up to the point where they're no longer interacting with each other to create a liquid. So there's a lot of energy, then they will, spread out and they'll no longer interact. And that's the gas phase. Okay, what is a mixture? So a mixture is just adding 2 things together. Okay, you can have a mixture of air, so a mixture of gases. So the air that we breathe is a mixture of mostly nitrogen, oxygen, carbon dioxide, and a little bit of hydrogen and helium. Okay, that's a mixture of air and gases. You can have a mixture in water. You can have liquids that mix together. So alcohol and water, they mix very well together. That's a mixture. You can also mix solids together. So if I just take, I can take a piece of paper and I can stack paper together, and that's actually a mixture. Okay, and the last 2 terms that we need to go through here are going to be our volume and mass. So the volume is the space that molecule takes up or that solution takes up. That's the volume. It's the space. The mass is going to be related to its weight. All right, so I'm going to speed up a little bit more now here. So a lot of this is going to be a review. So I have pictures here for you. You can always go back and look at these. And I'll just define all of the terms here for each one of the pictures. So the next is going to be cellular anatomy review. And so it's always good to know your cell, because our bodies are going to be made up of how many cells? 30 trillion cells, okay? And that number differs a little bit. So, some people have a little bit more blood than others, and that can throw off the count. But an average human has 30 trillion cells, okay? So just to put that into perspective, the number of red blood cells that you have in your body is over 1 trillion. It's about 1.5 trillion. So we have a lot of red blood cells. Each cell has pretty much the same basic makeup with a couple variations, okay? How many different cell types does the human body have? About 250. So the classic structure here for our cells, we'll start in the middle. This is going to be the nucleus, and that's going to be where the genetic material is. The genetic material is your DNA, which is coiled around proteins, which then construct chromatin or chromosomes. So your chromosomes will have your DNA wrapped around special histone proteins. Okay. Now inside the nucleus, you're also going to have a special little nucleolus. The nucleolus is a special region in which you have transcription of the gene, an individual gene, into messenger RNA. And then the messenger RNA gets processed also in the nucleolus. We also have assembly of the ribosome in the nucleolus. Okay, now from there, let's go on to the ribosome. That's going to be next. So you have ribosomes in two places in the cell. You have ribosomes that are in the cytoplasm and ribosomes that are going to be attached to the endoplasmic reticulum. Okay, and ribosomes are an enzyme that will synthesize new proteins from the messenger RNA template. Okay, and where did that messenger RNA come from? It's a copy of the gene. Okay, so a ribosome is a special enzyme that's going to synthesize new proteins. Okay, and some of those proteins may be enzymes as well. Okay, so those are the ribosomes, and you can see those kind of scattered around and also attached here to the rough endoplasmic reticulum. So the rough endoplasmic reticulum, okay, that's also going to be a site for protein synthesis. But those proteins that are made in the rough endoplasmic reticulum are destined for either other organelles or to the cell membrane, or they're secreted out of the cell. So that's our secretion pathway. Okay, so the rough endoplasmic reticulum and smooth endoplasmic reticulum, they work together to make new membranes and new proteins that will become receptors and transporters that are embedded into the cell membrane. Okay, now there's another part of this transport system, the secretion pathway, called the Golgi apparatus. Okay, and this is a organelle that will act kind of like a post office. It tells every one of these new proteins where their final destination is going to be. So it kind of puts a final address stamp on it. So if it's destined to be in the cell membrane, it's going to go to the cell membrane. But if it's destined to go to the mitochondria, instead it will fuse to the mitochondria and add proteins there. So that's what the Golgi apparatus does. It acts like a post office to direct traffic. Okay, the next thing, these little green guys here, these are the mitochondria. Okay, everybody calls these the powerhouse of the cell. Okay, well, let's take that a little bit further. Okay, so the mitochondria is going to synthesize ATP energy by using oxygen as a fuel source. Okay, so it's gonna burn glucose, but it also uses oxygen. So all the oxygen that you breathe, almost all the oxygen that you breathe, goes to the mitochondria in each of our cells. Okay, and so that's where we use oxygen, and we convert that oxygen into, you know, a non-reactive water. Okay? But that's what the mitochondria does. So it breaks down glucose and produces ATP energy by using oxygen. All right, and then, so I've covered nucleus, mitochondria, ribosomes. Let's cover the lysosome. So the lysosome is also made here in the Golgi apparatus, and this is your mini digestive tract. So the lysosome is going to lyse things, okay? And so it's going to break things down. And so that's why it's called the digestive system. It's a little digestive vesicle. It's kind of a round little vesicle, and it will fuse to vesicles coming into the cell to degrade those fuel sources, those nutrients, into smaller micronutrients, which then can be processed by other enzymes. Okay, the centriole. So the centriole is going to attach to chromosomes during cell division. Okay, so the way that I always remember centriole is the centrioles, these are cytoskeleton fibers that attach to the center of the chromosome. So that's how you can remember centriole. It attaches to the center of the chromosome during cell division, and then it divides the cell into half, again, down the center. Okay, now a vacuole is the same as a vesicle. So these are just storage compartments, but they're membrane bound. So they have to have a phospholipid membrane around them. And so that's what a vacuole is. The microvilli, that's going to be these little extensions from a cell. They're not hairs, they're extensions of the membrane. That's a microvilli. So that they actually have enzymes and transporters all attached to these. We see a lot of microvilli in your digestive tract. The cell membrane, that's going to be a phospholipid bilayer. The cytoskeleton, that's going to be the scaffolding inside the cell. Okay, so there's these big protein girders or protein scaffolds that basically give your cell structure. It's basically like your bones in your body. Okay, if you were to shrink yourself down to the size of a cell and you were to just push on the cell membrane, you would find that these aren't like a water balloon. You can't just squish them. Okay, they're actually very firm, kind of more like squeezing an orange. Okay. Now the cytoplasm, that's our last little thing here. That's going to be a liquid matrix. Okay, it's not quite watery. It's more like a thin gel. Okay, and that's our cytoplasm. That's because there's a lot of enzymes that are embedded into that matrix. Okay, so continuing on with cells, we have some very specific cells in the body. And so some of those cells belong to our immune system and also, are transporters like red blood cells for nutrients and oxygen. Okay, so all blood cells are going to come from bone marrow. And that's what this picture is showing here. So all blood cells, including platelets, there's a specialized platelet that will make, there's a special cell that will make platelets. So red blood cells, that's going to come from a special precursor cell here. So we have stem cells that make all red blood cells. That's going to be our erythroblast that will make erythrocytes. Okay? And so erythrocyte is the same as a red blood cell. Okay, now erythrocytes or red blood cells only have a short duration or short shelf life. They'll last for 120 days and their function is to carry oxygen throughout the body. Okay, now platelets are used for defense, for clotting, breaks in blood vessels. So if we want to repair a broken blood vessel, the platelets will attach to those broken blood vessels and form a clot. And then we can repair the blood vessel and restore it to normal function. Okay, but that's the function of a platelet. And these are actually just fragments of a larger cell. And then we have our white blood cell. And the white blood cells, there's really two cell lineages. So we have the lymphocytes, and then we have the myelocytes. Okay, in the myelocytes, you have the monocytes, eosinophils, basophils, and neutrophils. And in the lymphocyte side, or lymphoids, these are the lymphocytes. So let's talk about each one of these. I'm going to start with our basophils. So I'm also going to describe really how we respond to pathogens. So the first cell that really responds to any kind of pathogen is our basophil, and they're the alarm cell. They sound the alarm to any kind of infectious agent that gets across our skin or gets into our body. So that's our basophil cell. It sounds the alarm for infection. So it's our early warning cell. The next cell, and these are the most abundant, are your neutrophils. Okay, so most of your white blood cells found in your blood are going to be neutrophils. And about 60% of white blood cells are neutrophils in your blood. They're the first responders. They're phagocytic, so they go rushing into an area that may have, some bacteria or a virus, or let's say you had a cut in your arm, that's going to allow bacteria to get into the body. Neutrophils will go in and they'll eat any of those bacteria and viruses that got across the skin. Okay, so those are your first responders. Okay, and then the next cell that comes into the area is going to be like the late phase response. That's going to be your monocytes. The monocytes, when they enter into that area, will transform into macrophages. Okay, so a macrophage is just an activated monocyte. Okay, and what they're going to do is they're going to help with repair. Okay, they're the cleanup crew. They're going to come in, they're going to finish off any of those pathogens that are still there, and they're also going to secrete hormones that repair the tissues. And the monocytes and macrophages also can activate our second line of defense. Okay, and the second line of defense is your adaptive immune system. these cells here are part of your innate immune system, or they're just cells that are non-specifically attacking pathogens. The adaptive immune system is specific, okay? And those are your lymphocytes. So that's your T helper cells. So you have T lymphocytes, and then you have B lymphocytes. And the B lymphocytes will make proteins called antibodies. And I'm sure you've heard a lot about antibodies with this COVID-19 pandemic, you know, and that's how we know that a person has protection against that virus. Our bodies make antibodies, and those come from specific lymphocytes called B lymphocytes. So that's written right over here. You should have that as well. The T lymphocytes, the T helper cells, they're going to help activate the B cells. And then there's a second type of T cell called a cytotoxic T cell. Those are, you know, the police of our cell. So the cytotoxic T cells, they will circulate through our body, and they will find cells that are either cancerous or infected with a virus or any intracellular pathogen. And they'll kill those cells to get rid of the infection. All right, so that's it with that one. Our heart review. So I wanted to just go through like the terms. The most important thing to know for the heart is going to be the chambers and the valves. Okay, and then some of the blood vessels that are leading both to and from. Okay, so we'll always start here with the right atrium. And so the blood vessels coming in are going to be your superior and inferior vena cava. And then the right atrium will drain right into the right ventricle. And the valve in between is the tricuspid. Okay, then the right ventricle will pump blood through the pulmonary artery. Okay, and the pulmonary artery is going to go to your lungs. Okay, and that's where we're going to have gas exchange. Okay, so carbon dioxide is released, oxygen is brought in, diffuses in, and then oxygenated blood comes into the heart on the left side through the pulmonary veins. Okay, and the blood then comes into the left atrium, goes through the mitral valve. This is also known as the bicuspid valve. It goes into the left ventricle, and then the left ventricle expels it through the aortic valve, and that then goes into the aortic arch, and then into the aorta. Okay, and this of course also branches to the head here. So you have the brachiocephalic, which branches into the carotids. Okay, and there's just a quick overview of some of the blood vessels here that are involved in the two pathways. So we have our pulmonary circuit, okay, and that's going to transport blood to the lungs for gas exchange. So we release CO2 and we take in oxygen. And then the other circuit is going to be the systemic circuit, okay, and that is governed by the left side of the heart. And so the common arteries that you need to know is just going to be the common aorta, and then you have the mesenteric arteries that goes to your stomach and to your small intestines. Okay, and the way that I remember the mesenteric is just, I mean, if you look at the small intestines, it kind of looks like, you know, just this long tube that's just kind of packed in there haphazardly. So it looks really messy. Okay, and so that's how you can remember that the mesenteric arteries go to your small intestines, because the intestines look like a mess. Okay, the renal, that goes to your kidneys, so the renal artery. And a lot of these also have duplicates. So you have the renal artery, renal vein, the iliac, that goes through the iliac bones in your hips down into your legs. So that's the iliac artery, and you have the iliac vein, which brings it back up. So after the iliac, it gets into the femoral artery and then further down. All right, and then on the way back, you'll have the hepatic portal vein, which that brings in nutrients from the digestive tract, and it first goes through the liver before it goes to the heart, so that we can filter off any harmful things that our, you know, intestines may have allowed to pass over or that got absorbed. Okay, now a couple other terms. A cardiocyte, these are the contractile cells that make up the heart. Okay, and semilunar valves, those are going to be your pulmonary valve and your aortic valve. The atrioventricular valves are between the atrium and the ventricle, okay, and that's going to be your tricuspid and mitral. Now, some people will get those mixed up. How do you remember that the mitral valve is on the left side? Well, it ends in L. So the mitral valve ends in L, so that's how you remember that it is on the left side. Okay, the other thing here is you can look at tri. And so if you look at RI, it kind of spells the beginning of right. That's your right side. The tricuspid is on the right. Okay, we have the pericardium. This is going to be a membrane around the heart, which contains pericardial fluid. And this is going to be kind of a way to remove heat from the heart as it's beating, because whenever muscles contract, they're going to generate heat. And so the fluid will remove the heat. The apex and the base. So the apex and the base refer to the heart looking like a triangle. So the point of the heart is right here. This is the apex. Okay, and so you can see the triangle right here, and it should point to your left foot. The base is at the top, and that's where your blood vessels attach. Okay, and here's a few more arteries and veins that you don't have to know all of them. The ones that have an asterisk behind them, they're good to know, but you don't have to know those. But the ones that are not in italics, you definitely should know those. And then I put a picture here as well, because this way you can actually see that, you know, there's a pair. There's going to be a subclavian artery and a subclavian vein. So it's an easy way that you can compare, and that way it's easier to memorize these. Now getting into the heart, so you're going to need to know a little bit of the EKG, okay, and the conduction pathway through the heart. So the conduction pathway goes from your vagus nerve, okay, and then it conducts into the SA node. Okay, so this is just like the electrical impulse that goes through the heart. The EKG is measuring the electrical current of the muscle. Okay, so it's a little bit different. The conduction pathway is just going to go from the SA node to the AV node, the atrioventricular node. Then it passes the current down into the bundle of His, which then allows it to separate into two bundle branches, one for the right side of the ventricle and one for the left side of that ventricle. So you have two bundle branches that then travel down and around the ventricle, and then they will end in what's called Purkinje fibers. And these are the little finger-like fibers that spread over the ventricle so that it will contract in unison. Okay, now when we look at one of these PT waves of an EKG, okay, the P is going to correlate with the depolarization, or depolarization is a fancy way of saying the activation of that heart muscle, the cardiocyte. Okay, and this is the depolarization of the atria. The atrium contracts first, so it pushes blood down into the ventricle, and the ventricle bulges out. Okay, when it bulges out, we can create more force, and so that's why we have first the atria contract, like kind of stretching and filling, maximizing the capacity of the ventricle. Okay, and then once that depolarizes, in this little segment, this little white segment there, that's when you have contraction of the atria. Okay, now the QRS section, this peak has two things going on. It has the repolarization of the atria. So repolarization means that it's reset back to normal, and it can do another cycle. And it also has the depolarization of the ventricle. So both of those two things are going on simultaneously. And that's why you see a bigger spike here. The contraction of the ventricle is right here between the S and the T wave. And the T wave is when we reset or repolarize the ventricle. So we reset the ventricle so that it can do another round as well. Okay, and so we just have consecutive, we have consecutive depolarization, contraction, repolarization, and restoration of the muscle cycles. So we just have these cycles that go over and over and over. Okay, next up, these are going to be, I think a little bit more familiar with for you guys. So the digestive system, a lot of people know, but these are the main terms that you need to know. So the pharynx is made up of 3 regions, the oropharynx, okay, so that's going to be the mouth, oral, and then the naso, that's your nose, the nasal cavities. So the nasopharynx goes from your nose all the way back to your throat, and then the larynx. So that's going to be just above, okay, and that connects with the esophagus to carry food down into your stomach. Okay, we have 2 special valves called sphincter valves, and sphincter valves are just muscular, circular muscles that constrict, and that closes them off. So you have an upper esophageal sphincter that prevents food from getting into your voice box. And then you also have a lower esophageal sphincter that prevents food from escaping the stomach and going back up the esophagus. The stomach has 4 regions. The cardiac region is the highest region because it comes close to where the heart is. The fundus is where the esophagus attaches. So the cardiac is where the esophagus attaches. The fundus is the uppermost region right here. The body is most of the stomach. So this whole region right here is the body. And then the little curve here, this elbow, is going to be the pyloric region. And that's where you have another sphincter, a valve, the pyloric sphincter. And that protects the small intestine. Your small intestine, that's going to be the duodenum, jejunum, and the ileum. Okay, and that's the order. The duodenum is first, okay? And then the jejunum, that's going to be most of the small intestines. And the ileum is the final little connection into the large intestines. And this is where most of your nutrients are going to be absorbed into your body. Your large intestines, okay, the waste material is going to enter into a special holding area, which is called the cecum. And the cecum is where the appendix is attached. Okay, and so that's this vestibule right here. And then you have an ascending colon, transverse colon, descending, and then you have a little S curve at the end for the sigmoidal colon. And the colon is there to really balance out and absorb water. So this is where we can kind of absorb a little bit more water and balance out water in our bodies. The ileocecal junction is just where the small intestine attaches to the large intestine. And again, that's where we have the appendix. Okay, the haustrum. So if you notice, each of the colon segments has these little segments. Each of those segments is called a haustrum. Okay, and food moves through the digestive tract in 2 different ways. So there's 2 ways that we move things through. One way is through muscular segmentation, and that just means that it contracts in a circular manner by a circular contraction, and that produces segmentation. And the other one is peristalsis. So these are transverse movements that move food and waste a long distance. And then the diverticulum, that's going to be this little ligament that runs over the surface of the large intestine. You only have the diverticulum in the large. Okay. And then, of course, the large intestine is going to empty into the rectum, and waste material is held there by rectal valves. And then you have the anus, which is the opening to the outside, and you have 2 sphincters there that control the anus. Okay, remember that absorption occurs here in the digestive system, okay? And just make sure you keep that separate from what's called reabsorption. Reabsorption is going to occur in the urinary system. Okay, our respiratory system is pretty basic. It's an extension off of the digestive system. So we had those same early components, the pharynx, which is the nasopharynx, and oropharynx. So you can either breathe through your nose or your mouth. And then that goes into the pharynx. And that's good. The pharynx and then into the larynx. The larynx is going to be where your voice box is. And you can see there's some specialized cartilage here. So this is going to be your thyroid cartilage, and your cricoid cartilage is right below. So this is where your thyroid would be. And right behind that, that's also your Adam's apple. Okay, right behind that's where your voice box is. Your voice box is just a set of two pairs of stretched, basically stretched cartilage. Okay, and they vibrate and create noise. Okay, so we have a lung, we have alveoli. These are the specialized air sacs. That's a picture of one right there in which we do gas exchange. Bronchi versus bronchioles. Okay, bronchi are going to have cartilage. Okay, so they can't fully close. Bronchioles no longer have cartilage, but this is where you can do bronchoconstriction and bronchodilation. Okay, so bronchioles. And that also connects to the alveoli. Now, what cleans the lungs? So we have a special system that cleans the lungs called the mucociliary escalator. Okay. Part of our respiratory system is also our vocal cords. Okay. Again, those are just little cartilage flaps that, that will vibrate. And then we also have a pulmonary and a respiratory segment. So the pulmonary, to remember this, the pulmonary are the pipes. Okay. In the pulmonary system, there's no gas exchange. Okay, so these are the pipes that bring air down into your lungs and down to the very final segments. And this is the final segment right here. Okay, this is where we actually have gas exchange. So this would be the respiratory branch, where you have the respiratory bronchioles. That's the small little tube here leading to the alveoli. And gas exchange can occur here and in the alveoli. Okay. So that's how you can differentiate between pulmonary and respiratory. Pulmonary are the pipes, it's just a passageway. And the respiratory is where you have gas exchange. Okay, now a couple other things. So we have, of those bronchi, we have two primary bronchi. So that means it branches to the left and the right lungs. Okay, so that's our primary bronchi. The secondary bronchi branches into each lobe of the lung. Okay, and again, all of these have cartilage in them. Okay, and so we have 3 lobes on the right, 2 lobes on the left. You know, there's only 2 lobes on the left because it has to make room for the heart. Okay, and then we also have a tertiary bronchi, and that's going to branch it off even further in each of the lobes. Okay, and by the time we get down to the bronchioles, we have a diameter of about 1 millimeter. Okay, we can still see these, but they're just very, very small. Okay, and so that's our bronchioles, and those are going to branch. So we have our terminal bronchioles. That's the end of the mucociliary escalator, and then that branches to the respiratory bronchioles, which are attached to the alveoli. Okay, now the only thing I didn't mention here is the epiglottis and the diaphragm yet. So the diaphragm is the specialized muscle. It looks like a U shape, and it follows the bottom of your rib cage. Okay? And so that U shape, when you inhale, it contracts and it moves down. Okay? That's going to stretch your lungs and expand the volume, okay, which decreases pressure in your lungs, sucking air into your lungs. It creates a vacuum. Okay? When you relax your diaphragm, it goes back up. That makes your lungs smaller, which increases the pressure inside your lungs, and it pushes air out. Okay? And so that's basically how we breathe. So 2/3 of your breathing is controlled by your diaphragm. The other third are by your intercostal muscles in your chest and your rib cage. All right, and then we have, oh, let me go back, sorry. And then you also have the hilum and the carina. The carina is just this little special saddle piece of cartilage right there. And the hilum is the special opening for blood vessels and the bronchi to enter into the lung. So you'll see hilum in a lot of different organs. The lungs have them, kidneys have them. It's just the opening, and there's a membrane around it. So it's a sealed opening into the organ. That's a hilum. All right, next up. So we've got the urinary system. And so the urinary system is, its function is to filter nitrogenous waste out of the blood. Okay, so we have two kidneys that are the organs that will filter your blood. Okay, and our kidneys are extremely busy. They're going to filter over 150 liters of blood every single day, and they will reduce that down to just about 1 liter of urine. So half a liter to a liter of urine every single day. Okay, so there's a lot of blood going through them, but at the end, we're only producing about 500 milliliters to 1 liter of urine. Okay. Now, the filtering component of each kidney, of which we have about 400,000 of these units in each kidney, is going to be what's called the nephron. So the nephron is the filtering component of the kidney. Okay? And it's composed here of this special glomerulus. So that's going to be a specialized capillary. So we've got this afferent arteriole that goes into the capillary, the glomerulus, and then the efferent arteriole that goes out of this, the capsule and out of the glomerulus. So the glomerulus is held inside of a special capsule. We call that the nephron capsule. Okay? And then the glomerulus is a special capillary. Okay? And this is an important word that you should remember. It's called a fenestrated capillary, which means it's got little holes in it. Okay? And so it looks very much like a colander or like a screen door. It's got little holes in it, and it allows waste material and any other also nutrients, so amino acids and glucose and salt, they can all pass through this little, this little colander, this little meshed capillary system. So there's little slits in it, and nutrients and waste pass through. Now, the rest of the nephron is going to sort out, like a recycling center, the good from the bad. So it's going to sort out the good nutrients like glucose and amino acids and some salts, and it's going to put them back into the bloodstream. That's called reabsorption. Most of that occurs right here in the proximal convoluted tubule. So 60 to 65% of all reabsorption occurs here. Okay, but it tackles the big stuff. Glucose, amino acids, okay, they all get reabsorbed here. The rest of it is going to absorb salts. And so this is also used for balancing off your blood pressure. So we have this nephron loop, okay, we have a descending loop and an ascending loop. Okay, and so on the descending loop, this is when you're going to have water. It's permeable to water. Water is going to go out. Okay, and then on the ascending loop, this is when it's going to pump out sodium and chloride. And so it removes salt on the ascending side. And the last little bit, the distal convoluted tubule, this is where we have hormonal control. So your antidiuretic hormone and aldosterone, they're going to interact with your distal convoluted tubule to regulate your blood pressure. Okay? And so here we can have the absorption, it increases the absorption of salt back into the bloodstream. And remember this, water always follows the salt. So if I'm pumping salt back into the blood because aldosterone has been released, okay, that means water is going to follow that salt back into the blood and my blood pressure is going to go up. Okay, now anything that's remaining here in the filtrate, okay, is destined to be urine. Okay, and so most of that's going to be urea, which is a type of nitrogenous waste. And most of that nitrogenous waste comes from the degradation of proteins. Okay, and that gets dumped into the collecting duct. So this is what we call a collecting duct right here. And if you notice, you can see these little fan blades in the kidney. That's actually the collection of about 80 to 100 of these collecting ducts from all of the nephrons in that region. Okay, from that kidney, the urine then passes through these calyces. So you have minor calyces, which are the little branches, and then this big opening here, that's going to be your major calyces. And that funnels the urine down into the ureter, which carries it to the bladder, The bladder then stores it for a while. The bladder can hold up to about 500 milliliters, and then you have the bladder's attached to the urethra, which transports urine out of the body. Okay, now the renal cortex and the renal medulla. So remember, medulla means middle. So the medulla is this region right in here. The cortex is the outer shell. Okay, most of the nephrons are in the cortex. Okay, and as you go from the cortex to the medulla, it gets saltier through the kidneys. All right, we're going to be done with that one now. So the next big one is the nervous system. So I tried to give you as many visual aids here as possible for the nervous system so that it'd be easier for you to go back and review. So this is going to be just the cerebrum. Okay, and the cerebrum has really 5 main parts. So we have the frontal lobe, the temporal lobe, the occipital lobe, the parietal lobe, and then there's also another insular lobe inside, but you can't see that one, and it's mainly just used for intercommunication. But these 4 lobes, you can see the frontal lobe, this is where you do your heavy thinking. This is where you do your critical thinking, problem solving. It's also related to speech and reasoning. And then also, this is related to voluntary motor activity. The involuntary motor activity is coming from your cerebellum. That's this guy down here. And then also from the brainstem. So these 2 together will do the involuntary movements. All right, and then the voluntary motor activity is right down this center line right here, where it's communicating with its partner on the opposite side of the parietal lobe, and that's body orientation. So in order to have voluntary control over motor activity, you also have to know where it's going. So this midline right here is an important part that divides our voluntary motor activity with our body orientation. So we know where our right hand is and we know where our left hand is, okay? And then we can control the voluntary movements of them. The parietal lobe is also involved in reading, okay, and also sensation. So a lot of our sensory information is going to be stored here in our parietal lobe. The temporal lobe, this is going to be our hearing, and also there's also some speech in the temporal lobe, and understanding language. So if you have any damage to your temporal lobe, it'll be more difficult to understand language. And then also our behavior is recorded here. And remember, behavior can be trained. So this is done in the temporal lobe. The occipital lobe, this is going to be our vision center. So both vision perception, color perception, that's all here in the occipital lobe in the back. And these also correlate with the bones of the skull. So you have a frontal lobe, parietal lobe, temporal lobe, and occipital bone for the cranium. The brainstem, this is going to be involuntary, so it's doing digestion, breathing, heart rate, swallowing, reflex actions go into the brainstem. All right, now this is going to be a picture of more of the components of the entire brain. So here we have the cerebral cortex, or the cerebrum. And again, some of the lobes are mentioned there. There's 3 regions here. So I want to make sure that you guys know, this is the brainstem right down here. There's 3 regions of the brainstem. Okay, so you have the medulla. You can see the spinal cord coming up into this little first bulb here. That's going to be the medulla oblongata. Then you have the second bulb. That's going to be the pons. And the pons helps regulate breathing. So it helps coordinate exercise with your breathing rate. So that's what the pons is doing. The midbrain up here, this is going to be also part of the brainstem. So you can see it's connecting up here with this middle part of the brain, which we call the diencephalon. So that's this term right here, diencephalon. That's the middle part. And this is the most ancient part of our brain. Okay, this is where we have the thalamus and the hypothalamus. We also have, this is where we have hormonal control and hormonal activation. So if you think about the brain actually has 2 ways that it's communicating with the body. Okay, it's communicating through electrical signals down nerves. And then it's also communicating with the body, which is and this is a slower route, through chemicals, which are hormones. And that transition takes place right here in the hypothalamus. So the hypothalamus, the pituitary makes up this is our global regulator of our hormones. Okay, and it also is related to controlling it's controlling some of our impulses. It controls growth, controls metabolism rate. It controls sexual desire, things like that. That's all controlled here in the diencephalon. Now, just above this, you have this special structure called the corpus callosum. And this is a series of nerves that connects the right hemisphere and the left hemisphere. So there's a whole bunch of nerve branches here. So it's all myelinated nerves that connect the right and the left hemispheres. Okay, now this structure over here, you can see this is the cerebellum. And there's 3 lobes to the cerebellum. And so it's kind of related to the axes, so like the x-axis, the y-axis, and then you'll have a diagonal axis. And that's what the 3 lobes are for. They help you with regulation of balance and coordination. Now, the infundibulum, that's going to connect the hypothalamus with the pituitary. Okay? And the thalamus is going to be directly connected to the hypothalamus. But the thalamus is not related to the hormonal production. The thalamus helps regulate body temperature and homeostasis. So it helps regulate all the normal systems of the body, such as like heart rate, pH of the body, and things like that. Attached to the thalamus in the back here, this is where your pineal gland is, and that helps regulate your sleep and wake cycles. So it helps you go to sleep. And that makes melatonin, so that helps you sleep. Okay, so the sulcus and the gyri. So you'll see these grooves. And all of these grooves here, these are your sulci. So you can see this is the central sulcus, going kind of right down the middle there. And then, so right down the middle here, that's your central sulcus. And then you also have the gyri. The gyri are the little coils, okay? And these gyri will actually move. As you are learning a new skill, these gyri will change shape. And you'll have an accumulation and an abundance of new neuron connections. So we make new neuron connections by attaching an axon to another nerve cell, a neuron. Okay, and so that increases the density of those axon fibers. Well, if you have an increase in density of the axon fibers making new connections, okay, that changes the gyri pattern. And it kind of locks in those skills too. That's why you can't forget how to ride a bike. Or if you learn a musical instrument, you can often pick up that musical instrument years later after never touching it and still play a few songs because those axon connections are still there. Now, over a long period of time, you can repurpose those same axons to do some other function, some other skill. Now, this is the basic cell structure of a neuron. So here we have the same cell body. Okay, the nucleus is in the middle. Okay, so the same cellular components. You have the mitochondria, lots of mitochondria for a neuron. And then you'd have like the endoplasmic reticulum and the Golgi and all those things. Now, the receivers are your dendrites. So they're what receive signals from other cells. And they are connected then to an axon. So the transmitter is your axon. Now, you have myelinated axons and you have non-myelinated axons. So by adding myelin sheath, you will actually increase the speed of conduction about tenfold, so 10 times what you would normally have for unmyelinated. So they can travel at about 30 meters per second, where an unmyelinated one would travel at about 3 to 10 meters, really about 3 meters per second. So it greatly speeds up the conduction signal. Okay, but this is our axon, and it's going to terminate here. So it'll either terminate with another neuron at dendrites and connect there, or it will attach to, you know, a muscle or a gland, and it will trigger the release or the contraction of that muscle. Okay, now the myelin is actually produced by a special cell called a Schwann cell, and this is found in the peripheral nervous system. In the brain, this is what we call an oligodendrocyte, but they're similar in nature. And of course, at the axon, we're going to release a neurotransmitter. That neurotransmitter is a chemical that's going to trigger a response when it binds to a receptor on the other side at its target. So whatever the axon terminal, this is where it's going to release the acetylcholine or whatever neurotransmitter it may have. It's going to release that across a synapse and then to a target cell. And that will then bind to an acetylcholine receptor. And that's going to cause a depolarization event, which leads to the activation of that cell or that target. All right, a couple more terms. So like when we look at the brain and the spinal cord are going to be surrounded by a very, very tough membrane called the meninges. Okay, and there's 3 components of the meninges. So you can see this is the meninges right here. This is the bone, and then right underneath the bone is the membrane. That's our meninges. So you have the dura mater, the arachnoid, and the pia mater. Okay, and circulating through this, you also have cerebral spinal fluid, CSF. Okay, so that's our meninges. This is our spinal cord cross section, and so you can see this is going to have an afferent sensory information. So the afferent sensory information is going to come into the spinal cord, and the efferent is going out. So on the bottom here, that's going out. And so all of your sensory information is going to go up the posterior spinal cord. So basically it's a divided highway. And you can see the anterior is taking all of your efferent. That's going to be your motor neurons. So your motor neurons come down the anterior. The sensory information goes up the posterior spinal cord. Okay. Sensory information is always afferent. It's going to the brain. Motor neuron is always going to a target, and it's going down from the brain. So that's always efferent. And you can always remember E for exit. So it's going toward the target. It's exiting the brain. Now the dorsal root ganglion, that's this little bulb here. So this is where you have a junction from one neuron to another neuron. And so you have the axon that ends here. The dendrites are attached here inside the ganglion. And then you have the cell body of another neuron, which then makes up this white matter. This is the axon of this ganglion, which then carries the signal up that axon to the brain. Okay, gray matter. So when we look at the brain, your gray matter, that's going to be your cell bodies. Okay, that's where the nucleus is, and that's where the cell is. Okay, and then the axons, because they're coated in that myelin sheath, have a white appearance. So wherever you see white, that's going to be myelinated axons, and that's white matter. Okay, and you can see the white matter is in the middle. You'd have gray matter around the spinal cord. So the axons are all in the middle. The cell bodies are on the outside. The brain's a little bit different. The brain, it'll have the gray matter on the outside, and then it'll have the white matter kind of in between as well. The last thing we need to go through, and we're almost done, so we just have a couple slides left, a little bit of reproductive review. So we have the male and female reproductive systems. So I just wanted to kind of quick go through this, and you can fill these letters in as we go. But there's only one primary organ of the reproductive system for both male and one for the female. Okay, and that's in men, it's going to be your testes. In females, it's going to be the ovary. Okay, those are the only primary sex organs. Everything else is secondary. Okay, so everything else is a secondary organ. So the testes, that's our primary male organ. Okay, that's going to be located right here inside of our, let's see, it'll be inside, I know I have it inside the scrotum. Okay, so that's this outer one. That would be number one would be the scrotum, 2 would be the testes, and then the testes are really a coiled up tube. So this is our seminiferous tube that's coiled over and over and over, and then entrapped in a membrane. And so if you really took this whole thing apart, it would look like just a really long spaghetti noodle. And that long seminiferous tubule continues into this next structure, which is on top. So sperm is made in the testes, but they're not capable of fertilizing an egg from the testes. They need to go through a maturation process, and that takes place in this structure here. That's the epididymis. Now the epididymis will store them and activate them. It matures them so that they can actually fertilize an egg. It takes about 30 days. Okay? And then when they're called upon, then they will travel up this tubule here. That's going to be the vas deferens or the ductus deferens. Okay? And then that connects here with this seminal vesicle. Okay? And it enters into the prostate. The prostate is right here. And the seminal vesicle and the prostate are going to add fluids and proteins and enzymes to the sperm to make semen. Okay, and then all of that will pass out through the penis, through the urethra. Okay, and then just a couple of the landmarks. You have the bladder up here and the rectum. Okay, for the female, your ovary is going to be right here. This is where you're making eggs, but the difference here is that, you know, men, we continue to produce, 200 million to 250 million sperm every day. Women, you're born with only 2 million eggs. And as you go through puberty, you cut down the number of eggs to 400,000. So you have a finite number of eggs that can be fertilized. So you have 400,000 eggs, and if you go through all of them, then you won't be able to have a baby. Every time you go through a menstrual cycle, you activate 20 to 30 eggs. Okay, so by the time you do reach menopause, you're down to about 1,000 eggs. If you've never gotten pregnant. If you've gotten pregnant, then you'll have, tens of thousands left. Now that egg, when it's released, they'll pick out of those 20 to 30 eggs that are activated every menstrual cycle, and it alternates left ovary 1 month, and then the next month will be the right ovary. So it goes back and forth. But out of those 20 to 30 eggs that are activated, only one will be released into the fallopian tube, usually just one. Okay, and so we have the fallopian tube then that carries that egg down. Now, ideally, you want fertilization to occur right here at the outer end of the fallopian tube. And then the fertilized egg would migrate down into the uterus and attach to the uterine wall right at about day 6 of fertilization. Okay, and so we have our uterine wall, and then the inner lining is going to be the endometrium, and the outer line, the muscular section of the uterus, is the myometrium. Okay, the opening is the cervix, and then you have the vaginal canal that leads up to the cervix. All right, and then just some reference to always bladder and the rectum. All right, and the last thing that you need to go through are the directional terms. So they will expect you to know these for the TEAS test as well. So a lot of these come in pairs. So you'll have flexion and extension, okay? And you have superior and inferior. Superior is going to be toward the top, inferior toward your feet. Caudal and cranial, that's going to be, caudal is your tail, cranial is your skull. We use that more for four-legged animals or quadrupeds. Adduction versus abduction. So adduction means you're adding to your body, you're bringing your arms into your body, you're adding them to your body. Abduction means you're moving them away from your body. Superficial and deep. Superficial is, is very, it's outside, it's on the, like the skin. Deep means you're in toward the center of the body. Medial and lateral. Medial is the center. Lateral is the outside of the body again. Proximal and distal. So usually they have to give you a frame of reference here. So they should tell you it's either proximal or distal to what. If they don't tell you what it is, then you have to go to the heart. Okay, so if they don't give you a frame of reference, then just calculate that toward the heart. So it's either proximal or distal. Distal is further away, proximal is closer. Ventral and dorsal. So dorsal is the back, ventral is the front. Anterior and posterior, these are terms kind of like ventral and dorsal. Anterior is the front, posterior is the back. All right, and then the last thing here, we have the planes. So you have a transverse plane that cuts you horizontally. Okay, that's our transverse plane. Then we have the sagittal plane, and the medial sagittal line is cutting you directly in half, creating two equal halves, okay, or what we call like a mirrored image of yourself. So you'd have two equal halves. And then the last one is the coronal plane, and the coronal plane cuts you across this way. Okay. And that is it for the directional terms. The last two terms is anatomy and physiology. So anatomy is just studying the structures, and physiology is the function. And I always remember physiology because the PH sound, has an F sound. So if you think of function starting with an F, the PH, produces that same tone. All right. And that is it. So I'll go on and see if there's any of those questions in the chat. There weren't too many, so there's only two. Let's see. Didn't bring it up. I probably have to go out of the share here. All right. So let's see, is the conversion chart available during the TEAS test? You will not get the conversion test during the TEAS test, unfortunately. So that is something that you need to memorize. I would really focus on just concentrating on kilograms to pounds. So 2.2 pounds for every kilogram. And then you'd have, you might need to know centimeters and inches. So you have 2.54 centimeters for every 1 inch. And then there's an easy way to remember all of the increments for like the metric table. So if you start with gram, or if you start with liters, it's always grouped as 1,000. So you have 1,000 milligrams in 1 gram, 1,000 micrograms in 1 milligram, and 1,000 nanograms in 1 microgram. And then there's 1,000 grams in 1 kilogram. So just put those to memory. You don't have to go down to nanograms for that conversion. I would just say if you go from micrograms to kilograms, that you're going to be good for any conversions. The only other big conversion that they really have there is going to be is most likely going to be pounds and kilograms. They may ask you to calculate Fahrenheit. So Fahrenheit is going to be 1.8 times centigrade plus 32. So just make sure you might have something like that thrown on there, but that's also on that conversion chart. All right, and we'll be having this course again. Well, it's videotaped, so you'll be able to get the video if you need it. And yeah, and you can access the lecture at a later time. They should be supplying you with the PowerPoint too. And so you can use that to study off of, and you can re-listen to this. There's both the video and the audio. So if you don't want to, watch the video, you can go through just the audio component too. And just as a reminder, I highly recommend that you guys go through, talk to your admissions department, and just pre-register for that TEAS test. So when you pre-register, you'll sign up for a certain date, and that kind of locks you in. It makes you responsible for preparing yourself for that TEAS test date, okay? And then once you have that locked in, you also have 2 practice tests that come from that from signing up early. You also save $10. If you pass the TEAS test, Herzing will even reimburse you for the price of the TEAS test. So it's really to your advantage. Sign up early, prepay, get the practice tests, you know, and then you have this PowerPoint that you can go through and practice on, and then you also have the video or the audio as well to listen to if you need it. And you know, if you don't know a couple of the terms, you can look those up. So it really kind of helps you organize all the information that you need before the TEAS test, you know, and you can test yourself. You know, you can go through the PowerPoints, test yourself, see if you actually know all the terms. If you know all the terms, you're probably going to be very good on the TEAS test. And then also make sure you remember to look at those extreme modifiers. Pay attention to those. You'd be surprised on how often those come up on your answers. And so definitely make sure you have a couple of those memorized. But you know, I think it's somewhat intuitive once you know kind of like what you're looking for. The extreme modifiers are always going to be never, nobody, everyone. You know, so they're on the ends of the statistical realm. All right, any more questions? All right, otherwise that will conclude our webinar here on TEAS tests. And I wish you guys all luck. You know, if you just apply some of those strategies, I think you guys will be very successful. And don't forget to reach out to a loved one right before the exam too. You'd be surprised how much it relaxes you and helps prepare you. All right, have a great day, everybody. Take care and good luck.